All right. So first part is relatively easy. We're just doing function operations. Um, I hopefully you've seen the notation and stuff for this. The first part, all you're really doing is addition, subtraction, multiplication, division of your functions. So for like example 1, all this means is you take function f plus function g. So to write it out a little bit more, we're taking f of x plus g of x. That's all that means. So we take 3x minus 1 plus x squared plus 3x minus 2. So my answer would be x squared plus 6x minus 3. That's it. It's really, especially with the ones I gave you, it's just polynomial addition.
Wait, I wonder why is the x in the on where it says f plus g,
Mm-hmm.
then the parentheses x? Why is it?
It's just function notation, just like the x out here. It's just saying this is our function notation, f plus g of x. So it really doesn't mean anything special. I'm hiding behind the pillar. Okay, so subtraction works the same way. We're just taking g of x minus f of x. Now, with subtraction, you have to be a little bit more careful. Because this is where people get signs messed up. So you would need to make sure that you got x squared minus 1. Biggest mistake I would see usually on a quiz or a test is x squared minus 3. Because a lot of times people would apply the minus sign to the 3x, but then they would forget to apply the minus sign to the negative 1. Okay, what's the answer to number 3? 0. Whenever you're doing this, don't forget your basic rules. So many times I'll give you problems like this on a quiz or a test, and I'll see all kinds of work out here to the side, and then someone will come up with the wrong answer because they made a little math mistake. I give you these kind of problems so that you can give me an easy answer. Whenever I take and do something and I subtract itself from it, I'm always going to get 0 for an answer. Same thing for division. If I ask you what f divided by f is, what's the answer? 1. So watch for those. Okay, multiplication. Same thing. Biggest thing with this is it requires a little bit of work because you have to simplify. But you're taking the f function times the g function. I have too many pens in my hand.
So you have to do that, like boil stuff.
Yep. So make sure you write out your work, because what I would do on a problem like this is I give you partial credit for writing that out and then full credit for having it simplified correctly. So let's see, that would be 3x cubed plus 9x squared minus 6x minus x squared minus 3x plus 2 So whenever I write on a test or a quiz, make sure you show all work. It's not because I'm going to take off points if you don't show all your work. It's because I want you to show your work so I can give you partial credit. Okay, these are the ones where you don't have to simplify. I can't spell today. I'm actually asking you not to simplify the division problems. The only time I'm asking you to simplify is if I give you something like f divided by f, I'm looking for the answer of 1. But otherwise, please do not simplify these because you're going to do it wrong. There's very, very rare of an occasion where I ever see anyone simplify them correctly, because I intentionally give you ones that cannot be simplified, because I don't want you simplifying them. Like this one. This one cannot be simplified. I do it on purpose because we have not covered this yet, because I want to make sure that you will do it correctly. So I don't want you doing it until we go over it, because this is another place where I don't know, I want to make sure that you do it correctly. Because a lot of kids, if they were asked to simplify this, what they're going to do is they're going to cross out the 3 x's. And they're going to tell me the answer is -1 over x squared minus 2. Which is really, really wrong. So I'm asking you, please do not simplify those. To simplify those, you have to factor. So I'm going to give you things that are not factorable on purpose. Okay. So your book might give you things that are factorable. Still, don't simplify. Just leave it. All right. So those are your normal ones.
How do we do the division?
Leave it. That's it. I just want you to write it as a fraction.
Oh.
That's it. The only time I want you to do more with the division is if I ask you something like, if something is divided by itself, then you can write 1 for the answer. All right, compositions. The idea of this goes back to the idea of, if I give you a function, whatever I tell you to put inside that function goes in for x, right? Anything I tell you to put inside of that function goes in for x. Well, what we're going to do for compositions is we're going to take and we're going to put another function inside those parentheses.
Have you already done this?
Nope.
I thought we did.
We talked about function notation. So what compositions are is you take a function and you put it inside of another function. So those are compositions.
This is different from
Yes. It's not division. It's not multiplication. Now, the way we write this, the way we represent it, is with an open circle. A dot means multiplication, an open circle means composition. So, here, let me just show you on the first one. So this means this. So it means I put the function k inside of the function h. The second one goes inside of the first one. Now, a lot of times what I suggest doing, especially if you have a little bit of a problem understanding to start with, is to do it like this. Just to simplify it, we're going to do it like that to start with. So what I'm going to do is I'm going to take my function h, and I'm going to put k's inside of it. Sorry, I'm having a problem talking today too. So, I might start saying function. Yeah, let's just get the giggling out before I say it, and my N's are not coming out right. They're coming out as C's. What? Are we what?
Are you having congestion issues?
Yeah.
Yeah, so that's an idea. Whenever I get
My-
dry, I can
My tongue's getting dry. And
no,
okay. So h of x is equal to 2 times x plus 5. So the k goes in where the x is, right? Okay, so what does k equal?
x squared minus 3.
X squared minus 3. So I know I might be going a little slow, but I want to make sure that we understand this, because if we go too fast, I know we will end up leaving people behind. Okay, so from there we just have to simplify. So this is the idea behind it. We just take whatever k is and we put this inside of h, where the x was. So then we have 2x squared minus 6 plus 5. So we have 2x squared minus 1. Okay, I'm going to do one more like that, and then I'll try to go a little bit faster. Alright, so this one means I take k, and I put an m in where x is. Okay, I've already messed up, sorry. So k is x squared minus 3. I take out the x and I put m in its place. Okay, m is square root of x plus 4. Oh, I forgot my square sign. Okay, so now all I have to do is simplify. So my square and my square root cancel out. So there's my answer. Okay, so I'm going to go a little bit faster to this next one. This next one says I put h inside of k. So, k says I take x squared minus 3. So, instead of x, I have h, which is 2x plus 5 squared minus 3. You okay with that? So I take the h function and I put it where the x was in the k function. Okay, so then all I need to do is simplify. So now, remember, this does not distribute. This does not mean I square each thing. This means I FOIL. So this is going to become 4x squared plus 20x plus 25 minus 3.
Can you simplify?
That is simplified.
Wait, can we simplify it more?
Nope.
Why maybe take 2 out of...
No, you're not. That would be factoring. That'd be going backwards. Okay, one more. I just want to show you that you can compose a function with itself. So this would be that. So k is x squared plus 3. So I take out the x and I put k in for the x, which is x squared plus 3. Did I slow that one down a little bit? So the step before that looks like this. And I replace the k with what k equals. Oh, sorry. Sorry, is that what you're trying to tell me? Okay, FOIL that out. And now we get that. But there are plenty of times whenever you need to compose a function with itself. Go ahead. All right, so if we can compose them, then we can decompose them. So the idea of decomposing is just that you have a function and you take that function and you want to break that down into two original functions. Now, the only thing with this, sorry, is that you could possibly have multiple answers. So, you may not have one single answer for this. And I can show you this with the first one. Now, most of the time, whenever you look at this, you'll see one single thing. So what we want to do is we want to create an f function and a g function such that h of x is the same thing as f composed of with g. All right, so g needs to be like an inside function. So you want to find something, a function that is inside of something. So wherever you're looking at this, what is the first thing that looks like it's inside of something else? X plus 7. So if I put x plus 7 inside of f, what would f have to look like?
Square root of x minus 4.
Should it also be square root of x plus 7 x minus 4?
Yes.
Wait, but wouldn't x plus 7 be square rooted?
No, because if I'm taking this and putting it inside of that, then it would become square rooted whenever I put them together. Now, there is another possibility, and maybe this is what you're seeing, and this is what Teddy just said. Another possibility is this.
Can you speak about that?
Yeah, sorry. That's... I could also do it like that. That would still give me the same thing, right? Because whenever I take this and replace x with it, I would still get that function.
Wait, how would you get the negative 4 out of there?
What do you mean get the negative 4 out of where?
To make it square root of x plus 7 minus 4.
Okay, what we're doing is, what we want to do is if I take this function and insert it into this function, I want it to look like this function.
Okay, do they have to both be functions, or can you have like, could it be like square root of x plus 7 plus 10 minus x, and then just have a 4? Or does it
No, they both need to be functions. Right. Okay, so like on example 11. So what would your inside function be? X plus 3. This one's pretty much, you know, you don't have any real choices on that one. So see, on this one, if you took this and inserted it in here for x, you would get that. Okay, this one has multiple different choices again, but just give me one of them. Okay, so I could do that. So what would g of x be? X squared. So see, if I took x squared and replaced x with it, then it would look like this. Another possibility is I can make g of x 3x squared. Then wherever I replace, and then I could just make this x plus 4. Then I could replace x plus 4 with 3x squared, and then it would look like that. Yeah, sometime.
Do you always use f of x and g of x?
That's the way they word the problems in the book. They word them like this, or where's my other paper? They word them like this. Create an f of x and g of x such that f composed of g of x equals h of x. So they're asking you for f and g.
Only probably like 2 days on sickness and yeah, no, I'm almost done. I feel, like when you start getting breathe correctly. Yeah, I know, but right now it's done. Yeah, right.